All right, cool. We're on the Level Up stream. Thank you for joining us. We have Andy White, Arc White, Michael Skelton, Kadingo, and Sajib, Prodigy SML from Bugcrowd, and Jonathan Lightshoe, who's going to chat about CodeQL and SEML today. I'll hand it over to you, Jonathan.
Awesome. So the title of this talk is Evicting HTTP from the JVM Ecosystem Supply Chain, aka how I ended up generating 1,596 pull requests to fix an ecosystem-wide security vulnerability. Come on. A little bit about me. Hi. So I'm Jonathan Lightshoe. I'm a software security engineer. I currently work at Gradle Inc. Gradle is used to build 50% of all Java applications and 99% of all Android applications. So if you have an Android device, our software has somehow, in some way, managed to get the code that's in your Android app to your phone. And there's my Twitter. So why did I do this research? As with everything, ADHD, I just get distracted by random vulnerabilities and I dig into them and find them and they kind of get away from me sometimes. So all right. This starts out why is HTTPS important? Why is HTTPS important in the supply chain of the builds that you're, so Gradle and Maven are the build tools that are used to build and compile, Java projects around, the ecosystem. And the question is, why is HTTPS important? It's because if you have an HTTP connection, you can intercept that jar that's getting downloaded and inject additional code into that via man in the middle. This was actually there was a proof of concept written back in 2014 by Max Wietzman, who is now at GitHub, and he created a proof of concept that he created a proof of concept called Dilettante that actually intercepted jar files that were getting downloaded and injected malicious code into those jar files. Because at the time, back in 2014, Maven Sonatype, which was the biggest artifact host in the entire ecosystem, only supported HTTP. They support HTTPS if you paid, if you had a donation to the Apache Foundation. And so he, with the Twitter, shouted across Twitter and posted a blog post, and they fixed it very quickly. However, as I found out 5 years later, we still had a significant portion of the ecosystem still reliant upon HTTP instead of HTTPS across the entire JVM ecosystem for both Maven and Gradle. I'm going to say Maven and Gradle. Maven and Gradle, for those people that don't do Java development, are the two biggest build tools used in the ecosystem for building Java software. So the initial finding that I found is I was looking in a Maven POM file, in a Gradle build file, and I saw this in my code, and I was like, okay, how'd that get there? So what this is saying is I pull from a Maven repository, which is just kind of the formatted structure of how these jars are laid out, similar to NPM having, JavaScript code, Gradle file, or Maven artifacts, or Maven servers, artifact servers have jar files. I was relying upon this code, and I was relying upon it over HTTP, and I was like, where did this come from? Well, it came from, what I found out was it came from, I'd actually copied and pasted this code from the actual project that I had decided to pull this code from. And so I started there and started digging in and found this in more and more places. So this vulnerability in Gradle code looks like this. So there's 3 different kind of locations you can find this vulnerability in Gradle build files. In the build script, which is dependencies that are loaded on the class path for the entire build, meaning that for when you're building software, you have other auxiliary plugins that you use to build that software. Those may be plugins for like linters for checking your code and stuff like that. And then you have a repositories block, which is like where are the dependencies coming from that I actually use for compiling my code, like the compile time dependencies and the runtime dependencies for when you're running tests. So those are things that when I'm actually running the tests, I would actually be executing that code. And then this is when you're uploading that code to an artifact server, your build process is then taking that code that's been compiled and tested and run and saying, all right, here I want to publish as an official version. And so if you're using HTTP in any of these places, it could get compromised as part of the download or upload process to enable remote code execution or code execution. similarly, this is where you'd find in Maven files. Repositories are the compiled and tested code. Distribution management is where when you're uploading it, and then these are plugin repositories. This is the code that is running as part of the build. So like, you know, linters that get downloaded and executed in the same environment these jars are being built, or the so yeah, so in any of these places you could get code execution potentially in the build that's executing. Well, distribution management would be upload, so then you'd be impacting the artifacts that get published eventually. So who was vulnerable? The Eclipse Foundation, Gradle, Red Hat, Kotlin, so the Kotlin compiler, the Spring project, which is used to, by, you know, tons of projects around the industry, Jenkins, Groovy, which is another language written in Java, the Apache Foundation, the Elastic Foundation, JetBrains, all these different organizations. Who else was vulnerable? Oracle, the NSA, LinkedIn, Stripe. So I found this vulnerability in all these different open source projects of all these different organizations just by looking on GitHub. And I ended up using a very fuzzy search for finding these things. At the time, this is before CodeQL, before CodeQL was something that was on my radar. So I started out by just like looking and using very fuzzy GitHub searches and just going through pages and pages and pages of this vulnerability, and then looking for, you know, specifically in like LinkedIn's organization and seeing if I could find that specific vulnerable code path in those specific projects just by using GitHub's fuzzy search. Very monotonous project. I did end up getting some bounties out of it, not a ton. It wasn't worth my time as it all panned out, but you know, I found a lot of them. And so I did use the fuzzy search for these different URLs on GitHub to see kind of how much impact there was. For Maven uses, I found about 40,000, you know, you can read the table. So like for each one of these URLs, how many times did it occur in a Maven or Gradle file? And so this is kind of, you know, based on some fuzzy searches, and data can be skewed and you can end up with some things showing up not quite. But this is kind of the amount of numbers that you see if you search GitHub for these different URLs in these certain file types. So how do we fix this? So I spoke to Maven Sonatype, which is so in JavaScript, right, you have NPM, which is the biggest artifact host for node packages. Sonatype in the Java ecosystem hosts Maven Central, which is the predominantly used artifact host for Java packages. And when I spoke to them, they came back with results after looking at their network traffic for a month, and they said 25% of the Sonatype Maven Central downloads are still happening over HTTP. This is towards the beginning of 2019. So I pushed forward an initiative saying, okay, like given that we know that this number of projects are vulnerable, I pushed forward an initiative by talking to Maven Central, JCenter, which is owned by JFrog, saying, and Pivotal, which owns the Spring repository, and Gradle. And I said, let's all move together and let's break this one time across the entire ecosystem, entire industry. Let's all do this together, and it'll fix this industry-wide security vulnerability. And because of this initiative that I pushed forward, it actually successfully went off. There were some Stack Overflow posts of some angry users raging, but other than that, like, you know, the world continued and everybody started using HTTPS now. Yes, yeah, broken software everywhere. That is actually what happened. But it fixed a security vulnerability impacting the entire ecosystem and, you know, a huge swath of the industry. So enter CodeQL. I became aware of CodeQL by listening to the stream that GitHub put out about their purchase of SAML, which was the company that created CodeQL. And they said, we're, you know, and my first initial reaction was, that's awesome. They bought this company. Now they just need to create a bug bounty program around it. Lo and behold, wait a couple months later, they did, which is spectacular. So I wrote this very simple query at the time. And this is even before the bug bounty program got, I think it was before, no, this was just after the bug bounty program. I submitted a different query before the bug bounty program was founded, which I did get subsequently bountied post-bounty program creation by just submitting and saying, hey, I submitted this earlier, can I get bountied? And they said yes, which was awesome. But this particular query, if you remember back on the Maven Palm files, I wrote this very simple query that looks at the XML files and looks for the repository, snapshot repository, or plugin repository XML blocks, and then grabs the URL element and sees if the beginnings of that URL element match either HTTP or FTP, and then alerts on that. So very simple query, and they gave me a $2,300 bounty for this. Just very simple code, and also the documentation that goes along with it, which is a HTML document that you write up just to describe it. It very minimal amount of work, decent bounty for it, which is pretty spectacular. And now if you go into lgtm.com and you look for this query, if you use their search and say, look for Maven, you'll see this query pop up, and you can scroll through their results and see every single project that they've indexed that has this vulnerability in it. And you can just scroll through pages and pages and pages of vulnerabilities, which is really, really cool. Because, then you need to scroll through pages of vulnerabilities and really find that one organization that's vulnerable, report it to them. And maybe get another bounty so you can, double dip with other organizations where you find these vulnerabilities. And then on top of that, I'm sitting there, I'm like, okay, so we have all of this data of where this vulnerability exists. And the CodeQL guys, they've, from running this query, they've run this query against all of the projects they've indexed. Now that we know where this vulnerability is, what can I do with that? So I said, I probably could generate pull requests for this. And so at the time, yeah, right, open source vulnerabilities. Why don't we kill them? Just kill them with fire. So at the time, I don't think this is quite how they have it written out anymore. But the way that they had the bounty program written out is they have the one all for one, one for all, which is you contribute a query to the CodeQL project, and they bounty you for it, which was the $2,300. And then they have the bug smasher, bug hunter, which is basically like you write a query and you use that query to find 4 vulnerabilities and work with those maintainers to fix that vulnerability. And I said, well, and the upper limit on that was $2,500 for the bounty for that. So I did some math and I figured, 4 vulnerabilities, fix it $2,500. So there's 1,700 repositories with this vulnerability, do some math, and you'd come up with, so no, that was not going to happen. But, you do some math and you see, yeah. So how did I do this? I used the GitHub Hub CLI, and I used GitHub and the async IO, and a lot of hitting the rate limiting API that GitHub has all at once. Yeah, right, exactly. And I live streamed the whole thing when I actually after writing my bot, I live streamed this process of, automatically creating this many pull requests. I actually only needed to create 1,500 because the other ones were not actually vulnerabilities, or it had been updated and the index for lgtm.com was out of date. But whatever, at the end of it, I ended up creating 1,596. One of them was my projects that I was using as a demo, and I ended up with my own pull request created against it. But yeah, so 1,596 pull requests. At the time, a couple hours later, I'd had 2,000 pull requests, 2,000 files fixed, and 179. So this was February 11th. Yes, my GitHub notification feed. Yep, and I use that for work too, because I work for Gradle, which is an open source project, and we have GitHub for our, so mash those two together. But yeah, so and I took this picture when I created the slide deck. As of that now, there are 5,004 closed pull requests. So they've either been merged. So the pull requests have either been merged, they've been closed, and the maintainers have fixed them. So I'm going by so merged is the most common thing. Closed, the maintainer fixed it themselves in a different way, was the second most common. And the third most common was they just closed it, which is probably 20 of those, maybe less. And GitHub took it and gave me a $4,000 bounty for this. So I'm really, that's awesome. Thanks to the GitHub security team. Yeah. And so that's, my little jaunt into CodeQL. I have another couple of queries that I've written for a couple of different other projects and have been bountied for a couple of other different things. But this is a slide deck for this particular vulnerability. Yeah, so I'll open it up to you, Casey.
I'm keen to hear from the other guys. It sounds like, I mean, the rip your GitHub notifications part. It's like, yeah, managing, trying to do like QA across so many different repos at scale as an open source contributor. That's it's one of those like bite off more you can chew and chew like hell type of things. But yeah, Michael, like Andy, what do you guys want to ask about this?
Yeah, I guess. What's your future plans with it? So I'm guessing there's a whole heap of edge cases you could throw at this, like I don't know, handling like if a pull request gets closed by Stalebot to go back and reopen it and stuff like that. Like, are you looking at continuing it or?
So yeah, so there's been a really interesting, so GitHub, actually the GitHub security, because I open sourced my bot that I wrote, the GitHub security lab team actually took the bot and used it themselves to fix a C++ vulnerability. Or no, sorry.
Oh, that's cool. I love it.
They actually took the thing and said, like, there's this common vulnerability that we can write a bit of Python around. One of the things that I found out with, you have to preserve formatting because nobody will keep your code if you don't preserve formatting. So that's one of the big things that you have to make sure you take care of. But for future with this thing, I have another query that I'm working on around insecure random number generation, and I found a vulnerability in a code generator, and this code generator was used to generate, there's currently 15,000 repositories on GitHub that have been generated with this vulnerable random number generator, and it's in this very like fixed location in a class in a Java jar file. And so scale it up, go to 15,000 repositories that I have to make this change in, and that's my plan. I have to write the query. I've written the first part of the query, but I need to make it specific to that. I want to write the generic version to submit, but I want to write the specific one to that particular vulnerability so that I can get that all classified and then narrow it down to the specific files that I want. But that's my plan for following up with that vulnerability. Unfortunately, due to a bunch of issues that I've had this past summer, I haven't had the time to finish that query, but it's top of my list for come September if I have the opportunity. So yeah,
That's awesome.
Yeah.
So, yeah, no, it's really cool. I love it.
The other query that I wrote, here, let me just pull this up and I'll share my screen. The other query that I wrote was this one. So I found my one of the products that my company uses is a library called Ratpack. And I found in that library that we had an HTTP response splitting vulnerability, and I rooted that out to a root cause, which is very, very simple. It's in Nettie, if you're using Nettie, if you disable, you can basically, if you pass false to the HTTP header constructor, you end up disabling the header validation that basically allows an attacker that can control the header values to do CLRF injection, which lets you control the entire HTTP stream. And so I wrote a query. If you go up here, so this is the LGTM website, and you can you can hit search, look for queries that have already been written, and then if you find a query that you're interested in, you can open up that query in the query console and see the actual code and this code is checked into GitHub, but it also shows up here. And so this was very short query that I wrote to find insecure Nettie object creation. And this flags, if I go back to the alerts, I've actually checked out most of these, and they're not actually vulnerabilities because of they do checking themselves because they've decided that they're going to put manual checking in instead. But I did find a couple of vulnerabilities that actually existed with this vulnerability because of this disabling of checks. One of the ones that I found was in a project that's very widely used by the Groovy ecosystem called Micronaut. But the vulnerability wasn't HTTP response splitting. It was actually HTTP request header injection, which meant that it wasn't their server response that was vulnerable. It was that I could inject additional headers into an outgoing client request, which meant that I could inject another post body request into a header value, which leads to some really interesting things. And that actually got covered by Portswigger in their Daily Swig their news platform. So yeah, fun stuff there.
I was wondering that for anyone who's new to CodeQL and, this entire concept, how would you go about learning, the entire syntax and how to actually go and write one of these queries yourself? Would you have any resources you'd recommend?
Yeah. So they have. Let me share my screen again. They have this training. They have this Learn CodeQL thing. And so if you go into for Java, they have this learning CodeQL. They have a bunch of training docs, and they have I always say that syntax is similar to SQL, but not. It's interesting to wrap your head around. There's like I haven't worked with a similar language to compare it to, but they have this tutorial that they walk you through called Catching an Arsonist, where they have some example data, and the goal is, okay, given all these different preconditions and this set of population that they already have encoded, can you figure out who the arsonist is in the community? So I can find it. Anyway, so yeah, if you look up arsonist in the CodeQL tutorials, there we go. Yeah, introduction to CodeQL, find the thief, catch the fire starter, crown the rightful heir, and cross the river. These tutorials that they have are really, really useful to getting you into the language itself. The other thing that I found really useful is looking at other queries that have been written. So, going into they have, you can look for eval. So one of the things that I've done, and I have found vulnerability this way, it's very, very slow, but you can find, okay, call to eval like DOM function, right? You can look at the query that they have here and see, this query, kind of try to wrap your head around it. The other thing that I like to do, this doesn't answer your question directly, but one thing you can do is you can just scroll through these things and find vulnerabilities and report them to repositories. And I've gotten a couple of CVE numbers just off that. Lesser likely to find bounties just because the signal to noise ratio can be higher if you're just scrolling through this, because a lot of these are one-off projects that aren't used as libraries or were just somebody's side project. But every once in a while you find some interesting ones. Like I found a code execution vulnerability in a project called Mongo Express, which is a UI for the MongoDB database, and that has a CV number for it now. So
yeah, I wonder if there might be particular rules that have been written for very specific cases that might have more generalized application if you kind of spend a bit of time playing with them.
Yes. So they will according to the GitHub bug bounty team that runs the program, I've talked to them, if you take one of the existing queries and you modify it because it helps you find vulnerabilities, they will still bounty you for that. So you don't need to build your own thing from scratch, right? Cool. As long as your thing that you work on finds a vulnerability or finds a couple of vulnerabilities, and you work through the process of reporting it and disclosing it and getting a CVE number, right? They will bounty you for those things. So, yeah.
That's awesome. Very cool. It was
so I noticed
random selection there. That chili, yeah, and I just seen chili controller pop up in there and thinking, hang on, that's from DDWRT, and you just kind of randomly. All right, so maybe that's applicable across other access points or other, open source bits of firmware that use, I think it's a captive portal, chili WRT, on top of, there's all sorts of specific quirks to that particular implementation.
Yeah.
Like trying to munge this stuff up and seeing how more broadly it applies is a pretty interesting use of all this. Sorry, Andy, go ahead.
Sorry. Yeah. So I noticed going through the documentation on, is it pronounced Semle?
So Semle is the company that used to own it, but they've been absorbed into GitHub and now. So one of the things that's happening now is you notice they have the LGTM.com website that has these query results. They now have an early beta of these data points and these queries actually running against the security ones, because they have queries that are not security, they're like code quality and stuff like that. But the security ones, they are setting up a beta for actually running these queries against GitHub repositories as a GitHub action, and they actually get reported. So I think, and I can't be quoted as this because I don't actually know, but I can imagine that their goal is eventually that all of these CodeQL queries will eventually get run against every single GitHub repository by default, similar to how Dependabot is available against all open source projects by default. And the idea being there that GitHub, instead of you having to opt into these alerts, they will just automatically say, hey, you've got these vulnerabilities in your project, you might want to fix them. And that would have a significant, like, if once you get to that point, you have to have a very confident, you have to be very confident in your signal to noise ratio. But once you are there, you can eliminate just like vulnerabilities from huge swaths of the open source ecosystem, which is really powerful.
Right at the start of the supply chain. So that was kind of where my next question is going to. I noticed that most of the languages that CodeQL supports are reasonably typed languages. Yes. There is Python there, though, which is kind of a bit more on the dynamic typing end of the spectrum. Yeah. Are there plans to add support for more languages that you know of? Is someone working on that?
So I've actually seen members of the community, like there's somebody who is currently, and I don't know how far they will get with this, but there's somebody that's actively attempting to take a crack at adding support for Ruby.
Oh, cool.
So, and that's just, I think that's open source driven. The Go programming language is a separate project under the GitHub organization. So it's not under the CodeQL project, but it's under CodeQL Go. So, there are the languages being added. I'm a Kotlin developer. I'm a Java developer full time, but I also do a Kotlin development, and it'd be cool to see that because it's the #1 language used for Android now, but I definitely don't have the time to add it. So
well, it's good to know that someone can go in and do that if they want to. Yeah. Awesome.
Very cool. All right. Well, we might wrap it up there. Thank you so much, Jonathan. So Jonathan Lightshoe or J Lightshoe on Twitter. Is that how we find you?
That's JLL Lightshoe. JLL Lightshoe. I'll put up you can put up this. Yeah.
Put the thing up so everyone can find you at the end here.
Yeah. So you can find me here. And feel free, feel free to send me a DM or something like that on Twitter. So my DMs are open. Yeah.
Awesome. All righty. Well, thank you so much for your time, man. I really appreciate it. This is very cool stuff.